Whether you're deeply interested in energy systems or just trying to save money by making your home more efficient, you've probably heard about the potential for saving money with smarter electricity use. But how much control are you willing to give up to do that? In this video, we're going to dig into demand response, an approach that allows consumers to adjust their electricity usage to help balance the grid, cut costs, and reduce emissions. We'll explore both the benefits and the risks, how much flexibility you really need to make a difference, and whether exposing yourself to volatile electricity markets is worth it. I'll also share some personal experiences and practical examples, including the role of technology in making this all a little bit easier. I'm Rosie Barnes, an engineer with 20 years experience developing clean energy technologies and founder of Partalote Consulting, who provide advice to clean tech startups and investors. So, what exactly is demand response? Simply put, it's a method where electricity consumers adjust their power usage during peak demand periods in response to incentives or price signals. Electricity needs to be generated at the same time that it's used, and in the old electricity grid, that meant changing supply to match demand. So when you turn on your toaster, somewhere on the grid, a power plant is increasing its output a little bit to match that. And when you go turn everything off before you go to sleep, power plants will turn down as far as they can to reduce output accordingly. Now we're in the thick of the energy transition. We have increasing amounts of wind and solar power in the grid, and we can't just turn those up whenever we want. Solar in particular will have too much output in the middle of the day and too little in the evenings compared to the way that people want to use electricity. To make our new electricity grid behave like the old one used to, we can simply use batteries to soak up the excess midday power and fill in the gaps in the evening peak. But we can do better than trying to squeeze these new energy technologies into the shape that our old fossil grid had. And the way we can do this is demand response. The key idea here is that when the grid is under strain, it's just as good to pull some demand off of the grid as it is to bring more supply on. In practice, this means some more mindful energy usage patterns. The simplest implementation is to simply reduce demand when loads are very high. That might mean that at times of extreme grid stress, say during a sweltering summer evening, some homes' air conditioning will be turned off for a short period. And in industry, it might mean data centers or hospitals switching to their backup power supply when the grid is stressed. But in a bigger implementation, it involves not just reducing peak loads, but rather shifting the time that electricity is used to better match the times when electricity is cheaper and more abundant. So that will mean changing when you do energy-intensive things like charging your EV, heating hot water, running the clothes dryer. Or in industry, manufacturing or mining companies might save energy-intensive processes for during the middle of the day or overnight when there's not much stress on the grid. But can little changes like that really make a meaningful difference? You might be surprised to find out how little flexibility is needed to make a really big difference. A study performed by the Rocky Mountains Institute simulated the Texas power grid using demand flexibility in 8 common end-use loads to shift demand into periods of high renewable availability. They found that if hot water, heating and cooling buildings, EV charging, and 17% of plugged-in appliances like dishwashers and clothes dryers became flexible, it can significantly reduce the strain on the grid and lower costs for everyone, not just those who participate with flexible loads. Annual peak loads can be reduced by 24% and greenhouse gas emissions by 23%. And that 23% emissions reduction doesn't depend on any new wind and solar farms to be installed, it's just from making better use of existing capacity. In this study, curtailment of wind and solar reduced by 40%, and the value of these renewable sources increased by 36%. That would provide such a big incentive for developers of new wind and solar projects, likely having a big accelerating effect on the whole energy transition. So the future potential of demand response is immense, to be a key enabler of getting a lot of wind and solar into electricity grids fast. But clean energy wasn't the original motivation for demand response. Early adopters were more motivated by a desire to avoid the need to overbuild traditional generation like gas power plants and transmission line upgrades to deal with occasional large spikes in demand on the grid. So they instead focused on reducing demand during times when the grid was most stressed. In some US states, it now addresses over 10% of peak electricity demand. And over in New Zealand, they adopted demand response in 2007, and it now fulfills more than 16% of its peak demand through these programs. These early programs can mostly be described as central command and control. In this model, a central authority, like a utility company, remotely controls appliances and systems to balance the load. For example, they might lower your thermostat by a couple of degrees or suspend charging of your EV during peak times, or negotiate with an aluminium smelter to lower output for a while. This method ensures a coordinated and reliable response. A frequent critique of these programs is the discomfort of giving up control over your energy usage to the government or the utility. Can you trust them to manage that power responsibly? Will you end up overheating in the summer or get in your car only to find that its battery has been drained by demand response? Most demand response programs are opt-in, and many provide consumers with an override option, ensuring that you have the final decision. Additionally, the adjustments are intended to be minimal and hardly noticeable. Customers who have signed up for demand response typically report high satisfaction, which suggests that these concerns might be exaggerated. Nevertheless, such apprehensions could limit the number of people who want to sign up to demand response. One way to get around this apprehension about not having electricity when you need it is by having backup power, and that's where EcoFlow comes in. I recently got my hands on the EcoFlow Delta Pro 3 portable power station. It delivers 4 kilowatt hours of capacity with 230 volts and 4,000 watts output. And as your needs grow, the system expands up to 48 kilowatt hours and 12 kilowatts backup power, enough to power almost everything you need. I've even been able to use it as an emergency charge for my EV while I wait to get a charger installed at my house. It's much faster than plugging into a wall outlet. The Delta Pro 3 is easy to set up, just plug and play. And there is effortless all-in-one command with the EcoFlow app. Plus, it's whisper quiet, so you can run it indoors or outdoors without noise disturbance. Don't miss out on the early bird special price for Australia only, up to $2,600 off. And for other product bundles, up to $4,000 off, valid until October 31st. You can also find Delta Pro 3 offline through Anaconda, Battery World, Bunnings Online, Total Tools, and Harvey Norman. And you will enjoy a free 5-year warranty. Thanks to EcoFlow for sponsoring this video. Back to demand response in its central command and control type of implementation. Aside from worries about maintaining control over my own home's functioning, I also think that these systems are a little clunky, relying on occasional signals being sent out to people or appliances. Sometimes it's as unsophisticated as a text message asking consumers to please reduce electricity usage for a while. It can work decently well for industrial customers that have really high electricity usage rates that can be controlled with a single action, but for smaller customers and especially households, feels like a lot of faff for minimal gain for each individual. But all those individual small customers together represent a very meaningful amount of potential load reduction. So we don't want to make it so annoying that not many people will want to sign up. Then we would miss out on all that potential value. We'd really like to have as many people as possible participating and have as many electrical processes as possible becoming flexible. This will require more than just reducing load from large industries and the occasional major household appliance during potential rolling blackouts. We need to advance further. Rather than reacting to specific periods of high demand on the grid, traditional demand response programs concentrate solely on reducing load during peak times. However, what we need moving forward is demand flexibility that shifts consumption to different periods throughout the day while maintaining the same total daily electricity usage. Achieving this demands widespread participation and automation to make it frictionless, which I believe won't be achieved through a central command and control system. Instead, a market-driven approach supported by smart technologies holds much greater promise. This needs to be based around an electricity market where prices rise and fall throughout the day. In markets with large amounts of wind and solar generation, like here in Australia, prices can be incredibly volatile, and so there is a lot of money to be saved by shifting usage away from periods with little renewable energy in the grid when prices are high, and towards times when prices are low or negative. A flexible tariff allows consumers to trade those volatile prices, and if you combine that with a platform that provides real-time price signals, households can adjust their consumption and save a lot of money. And when flexible consumption is combined with distributed energy resources like rooftop solar panels and home batteries or EVs, a lot of money can be made. It's a more decentralized model, giving consumers more control and flexibility. But exposure to the volatile wholesale electricity market prices does come with increased risk, and there have been some early missteps by companies playing in this space. In February 2021, Texas experienced widespread power outages during Winter Storm Uri. As demand soared and supply plummeted, customers on variable rate plans, such as those with Griddy Energy, were hit with exorbitant electricity bills. These plans passed wholesale electricity prices directly to customers. When prices spiked to the maximum allowed, $9,000 per megawatt hour, some households saw bills exceeding $10,000 within a few days, which many couldn't pay, leading to Griddy's eventual bankruptcy. Another example came soon after. In 2021 and 2022, the UK saw a dramatic spike in wholesale gas prices. Similar to Texas, customers on flexible tariffs faced significantly higher bills. Smaller energy companies offering attractive, low-cost plans before the crisis couldn't absorb the costs when wholesale prices surged. As a result, over 30 energy suppliers collapsed. The UK government had to step in to protect consumers, but many households still faced higher than expected costs. But some energy companies were able to weather those storms during crises like the Texas freeze and the UK gas price spike due to prudent risk management and price caps that limited the size of customers' bills. Octopus Energy, for example, survived the Texas freeze by capping their customers' rates, protecting them from soaring bills. Similarly, during the UK gas price hike, Octopus stayed afloat because they had hedged their energy supply, meaning it had bought gas in advance at a fixed price, avoiding the massive price spikes that hit other suppliers. Additionally, Octopus's use of innovative tech allowed the company to manage usage more efficiently and offer smart tariffs that incentivized off-peak usage. Their strategies showed how effective risk management can protect both the company and its customers from market volatility. And hopefully, these lessons have been learned by other companies who are offering wholesale electricity market exposure to households. You can probably tell that I'm a big fan of demand response. In my opinion, it's the most powerful tool that we have to simplify the energy transition. Our new electricity grid doesn't need to function like the old one, and forcing it to do so would be highly inefficient. And I think that most people don't really get how transformative flexible demand is going to be, and so they massively underestimate its potential. There are still uncertainties to be resolved. For example, people say that a system with a lot of flexible demand would be too chaotic, that we can't rely on individual households to reduce demand when needed. So grid planners would need to design the system to be robust without it, which means putting in all the generation and all the transmission you'd need if there was no flexibility, thereby totally eliminating the point. I don't believe that will be the case, because the electricity grid already relies on households behaving in pretty predictable ways on aggregate. As an example, if every house in Australia turned their toaster on at the same time, it would create an additional 12 gigawatts load. That is nearly half of our average grid load. If that came on at once, it would crash the grid for sure. No one freaked out about the electricity grid when electric toasters started finding their way into every household. So now consider the question of EVs and the fear that is often raised that everyone will plug in when they get home from work at 6 p.m. That would be like the toaster example on steroids. That just cannot happen if we want our grid to continue to function. And so far it's not happening. Houses with EVs are commonly also houses with rooftop solar, and there are very strong financial incentives for them to use that solar power instead of sending it to the grid. So they tend to charge their EVs during the day. And houses with EVs and no rooftop solar are very incentivized to look for an electricity tariff that will allow them to charge at off-peak rates, whether that's midday or overnight. EVs are mostly still for early adopters, and we can't be sure everyone will be so cost conscious and so flexible. But the transition to full demand flexibility is not going to happen overnight, and we're learning consumer behaviour gradually as more people get on board. But can it ever scale to become mainstream? Another common criticism I hear about demand response is that no one is going to want to be inconvenienced. When people flick a light switch, they expect the lights to come on instantly. But many people are willing to make sacrifices to save small amounts of money. Every now and then I see articles about long lines at petrol stations because someone has dropped their prices. Their customers are willing to wait for hours to save maybe 20 or 30 bucks. The same principle will surely apply to energy consumption. But still, it's not everyone that's like that. We'll need digital technologies like smart chargers, smart hot water systems, smart thermostats to get much easier to integrate and much more popular before demand response can meet its true potential. But I do think it's inevitable that will happen. The difference in cost between a dumb electricity grid without demand response and one where it's widely prevalent is too great for it to not happen. There are already consumers saving real money by getting flexible, and as they tell their friends and neighbours and colleagues about it, anyone concerned about the increased cost of living, which these days is everyone, they're going to want in on the action. I think the biggest barrier will be in electricity grids that don't have a market set up, where there's no competition and no incentive for the monopoly utility to bother with the complexity. But again, in the long term, I'm optimistic that money will talk, and the people of, say, New Mexico, where the utility companies control the generation, transmission, and distribution of electricity with no wholesale market and no choice of electricity supplier for customers, they're going to see their Texan or Californian neighbours with flexible markets taking advantage of the lower prices that will come when demand response is fully implemented. And they are going to demand a piece of that for themselves. Thanks to the Engineering with Rosie Patreon team who support all my videos and chat on our exclusive Discord server about all things energy. And thanks to EcoFlow for sponsoring this video. And for everyone watching, stay smart, save energy, and I'll see you in the next video.